This webinar highlights the scan-to-scan with regions in Geomagic Control X. I appreciate your joining us today, and I hope you'll be able to join us again on future product spotlights as well. And now I will pass it on to Adam Varoxa, a Geomagic application engineer, as he's leading today's demonstration. Adam, it's all yours.
As Adam said, my name is Adam Waraxa. I am a application engineer with Geomagic, and today we're going to go over talking about scan-to-scan with regions in Control X. So often some of the things we're confronted with here is going with an inspection plan where we only have scan data. So there's either not a model provided, we maybe just have a drawing, or maybe we have some legacy known good parts. So we usually just dub this the creation of a golden part. So, and one way that we have to combat some of the ease in creating objects from this and creating features from this to actually inspect is using region grouping. This greatly speeds up the process and helps maintain something that's very consistent part to part for measurement schemes. So what this allows us to do is all of us inspect like we have CAD on the part. So you see all of these colors on the screen here, and they are all basically turned into objects that are much CAD-like. So as you click on them and use them, it'll automatically find planes and cylinders and cones and things like that for you, allow you to take measurements directly between them without having to go in and manually extract out features. The inspection plans based on the regions, we generally use them as a part of the repeatable inspection process. So once you lay out an inspection plan on what we call a golden part, you're going to use that again as a basis to inspect your future parts. And then we also use regions as a really great way to just do a single part. So maybe you just scan something in and you have a bunch of data, we can go in and region it, and then instead of having to manually pull out features that you want to measure off of them, they're all essentially created by the regions for you. So you can just go in, mention them, and put tolerant on them. And even with a single part, we usually just load the part and inspect it to itself, essentially, putting tolerancing on it from based what the nominal should be, and stuff like that. And it allows you to move pretty quickly through that process, also simplifying it out. So a little bit about regions is we use regions in a lot of our other products besides Control X. They've been used a long time in Design X and Wrap, things like that. And we use them there mostly for reverse engineering processes, so it greatly speeds up that also. So we've been doing regions for a long time, and we have these great automated extraction methods for these regions and long proven for accuracy and things like that. So it's just a natural progression of having stuff like this in your inspection products to speed that up. So what do we need here? So we're just going to go over. I made this little sort of test widget here, and then we got that in and scanned it up, and we're going to go through the regioning process in CX and how to lay measurements on the object. So let's jump into Control X. So as we open Control X, it comes into normal result data, as it always does. We're actually going to start in the input data section. So this is where generally everything is loaded regardless of where you start. It comes into input data in its raw state, essentially, and then just allows further result processing. One of the reasons we do this is because you can set up a lot of your files here as they come in, and then always push them to multiple results. So another benefit of CX, if you've seen some of our past webinars, is the ability to add multiple results with same and different data sets. So what I'm going to do here is I'm just going to pull in our original part here that I pulled in. So we're just going to grab our, I called it test thing, and we're going to bring that in. So you can see this is the STL of our part. I took some care scanning it both sides, line everything together, mesh it out from my scan, and it's sort of ready to go. So we're going to just come into regions at this point, and we're just going to use our auto segmentation tool first. Get a little warning here. We're regioning it, so we can use those later on. And I'm just going to leave this as is right now. So you can adjust sensitivity and things like that depending on how you want to break the part up. The more sensitive you add your region groups here, it's just the more regions you get. They're not any more, like the plane is a plane. If you had cranked the sensitivity up, it's not any more accurate. You just are probably going to segment out maybe some different areas of the plane. If it's not exactly flat, it'll divide it up a little bit more for you. So really depends on how much you want to look at it, but generally less is more. So I always start somewhere down lower in the bottom third here, and in preview or just hit OK. As this is segmenting out, you'll see a bunch of colors pop up on the screen here, and they will show you how we can highlight over them. And then often there are some things like, a lot of times on some like very shallow angles or things like that, it may not necessarily detect the most accurate difference between those areas. It actually did a pretty good job here. So, but we can show you how to adjust some of that stuff. So what I'm going to do is find an area where there's a little bit of encroachment. So you can see that this plane is actually encroaching into the crease here. So there's a couple different ways we can take care of that. One of the things that we can do is actually just insert a region. So if I want to, what I like to do is draw a line. So I will come in and draw a line here somewhere on the other side of my plane with just my draw tool visible on. And I'll actually just insert a region. So it threw that in on top of my part, and now you can see my planes are definitely segmented. Now we're not going to use this region anyway, so it doesn't really matter what it looks like. We're just interested in maybe taking the angle between these two. So that's just one way of dividing it up. There's another one here we can do. This is a very, very shallow angle on the back here, so I didn't expect it to get it out with, segment that out with where I had the sensitivity. So what I'm going to do is come in, and we're actually going to use the split tool this time around. And I'm actually going to pick limit to region. So it's just concentrating on splitting this region. If I drew a line across the part, it would split essentially everything, even including that top radius there. So what I'm going to do is just start outside of my region. And I'm going to draw, and you can see the polyline here is right on the mesh as it's following along. And I can click the line and divide it out. Now I'm actually going to do the other side of here just for fun. So we'll put that split in. I'm actually going to do one more on the other side of this polyline here, and it will just come out, and we'll just make sure we get like that very shallow radius out of our two planes. So one more technique to section them out. So now we have two segmented regions around the bend there. The other thing you can also do is highlight an area and just reset. So I could always come in and grab these two if I don't like it there. And we can do that now, actually, just highlight both of them. I could always come in and resegment and do that at a higher sensitivity. So I can turn my sensitivity up, and I can, again, hit preview or check. And you'll see as it runs the process again on these two areas, it's going to automatically divide it out. So it's going to break things up a little bit more from the standard region, so you can see we're actually getting some of this radius now if we wanted to and segment it out. For our purposes, this is not totally relevant. So now that I have a bunch of regions on our part, you'll see as I highlight over them, it's actually giving me the different planes and things that are here. If I come into our holes and stuff, so it pulls out cylinders of the holes of the countersink here, the plane on the top of the surface. So really handy little tool to grab everything for you. Normally I'd have to come in and highlight this data and then use a manual extraction tool to say it's a plane or a cylinder, things like that. So it greatly speeds up the process, does my whole part. From here, what I will do is I'm just going to add this to my result data. So now you'll see it pushed it to my result data. And then what I'm going to do once it's in result data, I'm going to push it to my reference. So now you'll see that it moved to reference as this is the thing we're going to measure against, and it put my colors back for my region. Now that I'm in reference, I can come in and just start doing dimensioning like I would on a CAD object that I brought in. So if I wanted to know the angle between these two planes, I can come in and just drop that in. Let me grab, we can throw another one on here. Why not? So like an angle between like this plane and the space here. Quite simply drop that in. Some of these are pretty round numbers, some of them are not. So like this one, I believe is something around 90 degrees here when I was playing with it the other day. We can pull all that stuff in, and on any of this stuff, we can actually add tolerancing while we're at it. So if I wanted to tolerance this to say maybe plus or minus like half a degree, I would just override that. What the tolerancing is going to affect is when we bring in measured data and compare to this part. So I can throw some of that on if I want to do some, maybe we'll do a linear dimension to some of these holes off of this face. So I'll do this to my cylinder center here. And I can drag that out there just so I can see it, and sure, we'll leave it at 50 thou. That's fine. We'll put that one in here. And you can throw just another one up here for fun. Between this hole and this hole. So you'll see the numbers that it's pulling off as reference here are actually what it's gathering from the mesh. So you have to remember that this is not a CAD model, so the things as measured are there from our actual scan data. So that's why some of these angles and things like that, and there's some of the lengths that I'm grabbing aren't going to have nice round numbers. What we can do is go in and override these if we like. So if I come into this 90-degree dimension here, that's a little bit over. When I compare to my standard part that I'm going to scan next, I'm going to say I want this to be 90 degrees. That changes that out and it tolerances it. So once that is done, this is essentially our inspection plan, just like we would have if we were setting it up on a CAD model at this point. And what I would do now is bring in a set of data to measure to. So bring in input data, and we'll come into the scan I did of a secondary part, import that out. So you can see I scanned the top of the part here and around the sides. Didn't bother to do the bottom, which is fine for what we're doing. Now I'm going to come in, and I could have pre-set up some types of alignment and things like that. What's nice about CX is the order of operations for some of these things doesn't really matter. So let's just do an initial alignment here on our part. That's going to look out and grab it and stick it on top of my reference object. And then I'm going to do a quick best fit, which is really going to tighten that alignment up. Once I do that, I'm going to let it rebuild all of this measurement geometry. So you can see right now it's all empty. It doesn't have measured data in it. Now it rebuilt it, and you can see that my tolerancing on my parts is really close because it was there was two of the same essentially printed objects that I've scanned, so they're all really quite tight to each other. So the tolerancing is very, very tight to one another. We don't have gross manufacturing defects anywhere, but that's kind of a quick way to pull things out. Now I would do a similar thing to this if I wanted to do the same part to itself. So instead of having this part where I brought in a secondary scan data, if I wanted to inspect this original part just on its own to, instead of drawings or something that I had, I can actually will show you that process now too. So what I'd actually do, I'm just going to duplicate the result just so I don't have to redo everything. And I'll come into result data too. And what I'm actually going to do is just get rid of the secondary scan here. I'm just going to delete that out. So now you'll see that I am stuck back with no measured data. I have my original part with my regions here. What I could always do is if I wanted to just inspect this to itself, anything that I click on the regions are actual measurements. But if I wanted to put override the nominal data and put tolerancing on it, I would fit it to itself. So what I could do is come in, and on my tags is I will say that this should be like 160 degrees, and then we'll put a half a degree tolerance on that, and hit OK, and we can say that this should be 28.5, and we'll put our tolerancing on that. And these are actually, I don't know if they're rounded, but we can check and see. Now it's finding 1.5 inches exactly on that, and it's saying 0.5 inches exactly on that. So it's very, very close. I have set to like 3 figs rounding error on here, so the prints are pretty close. So once this is done, I could actually import the same part again. So we're just going to come down and grab the same exact part into my file. And then if I hit rebuild on this, what it's going to do is it's going to do an initial and best fit alignment on the part that I brought in. So it's in here again. And then it's going to look at all of my tolerancing and stuff on my part. So now you can see that I have actual deviation and reference values, just like I would if I was inspecting a part to a CAD. But I'm actually using overriding essentially the nominal data from my first scan to put in the drawing dimensions on this part, and then inspecting it essentially to itself. So the fitting is perfect, but it's going to give me the tolerancing is it's going to show up if there is some actual deviation in my measurements here. It'll flag that out, but it's a really quick way to do a single part inspection process also. So then all you have to do is, set up your report, send stuff out the way you want, take any shots of views that you would like, and we are good to go. So that kind of concludes region grouping in CX. It's a really straightforward process. If we had some other data we wanted to bring in here that we wanted to inspect to at this point for our repeated, if I had several other parts, I could just use our replace measure data here and grab the part again and throw it in and let it run. It's going to automatically run through this process just like it did the first time. And it's going to replace this data with my next part. And then again, I can just update my report and send it out. And this is also useful. I can do all of this and set it up as it's a regular inspection plan. So I could still do our batch processing with it, things like that. Set up a watch folder for our automation server if I like, so we can still fully automate off of this region group process. And that is about it for regioning with CX, guys. So I'd like to thank you for joining us.